So we are going to solve a linear system with this row echelon form. This row echelon form might be the result of application of row operations to an augmented matrix of a linear system. And since we already arrived here, so it will be easier for us to solve for the specific variables that will correspond to the unknowns in your linear system. In this case, let us use x sub 1, x sub 2, x sub 3, x sub 4, and x sub 5. Start. We are going to come up with equations that are equivalent to the specific rows using, again, the mentioned variables. The first row would be x sub 1 plus 7 x sub 2 minus 2 x sub 3 plus 0 x sub 4, so it's just 0, minus 8 x sub 5 equal to negative 3. The second row, okay, you don't have x sub 1, you don't have x sub 2, you will have x sub 3 plus x sub 4 plus 6 x sub 5 is equal to 5. And for your last row, you will have, not last row, the third row rather, or the last row with non-zero entries, x sub 4 plus 3 x sub 5 is equal to 9. So we have these three different equations here. However, noticeably, we don't have a specific variable which is equivalent to an exact value. What we have is for our third equation, it's a combination of x sub 4 and thrice x sub 5 that will give us a value of 9. What we don't know what the value of x sub 4 is, nor x sub 5. In this case, this is already in testament that we have infinitely many solutions for the linear system with this row echelon form. Why? Again, because you don't know the exact value of x sub 4 and x sub 5. And further, we are going to represent one of them, say, let x sub 5 be an arbitrary variable, let's say t. This would be used to represent the rest of the variables here, and since it's t, we don't know its exact value, so it could represent any other variables. But we are just going to use this so that we could finish solving this linear system. Again, this has infinitely many solutions. Or you could also look into the instance that we have 5 variables here, x sub 1 to x sub 5, and we have 3 non-zero rows. So there is an excess of variables. We call them free variables. And actually it's 5 minus 3, so 2. So 2 of the variables here will be represented by a specific arbitrary variable and will be useful to represent the rest. Let's start with x sub 5, which is equal to t. This equation now will become x sub 4 plus 3t as your x sub 5 equal to 9. This means your x sub 4 is equal to 9 minus 3t. See, there's no exact value here, but we have a representation for x sub 4 using the representation of x sub 5, the arbitrary variable t. With this, we can now solve for x sub 3 using the representations earlier. So x sub 3 plus x sub 4, which is 9 minus 3t, plus 6 x sub 5, which is t, is equal to 5. Then we simply compute x sub 3 is equal to, you subtract 9 on both sides, you have negative 4. And since this will result to a positive 3t, but when you subtract it both sides, you will get a result of minus 3t. This is now your x sub 3. Now if we're going to look at our first equation, you have x sub 1 plus 7x sub 2 minus 2. You have now your x sub 3, which is, sorry for that. So you have 2 times negative 4 minus 3t as your x sub 3 minus 8. X sub 5 is t equal to negative 3. However, you still have 2 variables here, x sub 1 and x sub 2. As mentioned earlier, there are 5 variables and there are 3 non-zero rows. 5 minus 3, 2. This is an indication that there should be 2 out of those 5 variables that will be represented by an arbitrary variable, and they will be used to represent the rest. Since we already used t for x sub 5, let us try let x sub 2 be an arbitrary variable s. And with that, we could come up with, I don't know if it could fit here. Let's try. You have x sub 1 plus 7s. Let's try to compute now this grouping symbol. Negative 2 times negative 4 is plus 8. And then you will have plus 6t minus 8t is equal to 3. And finally, your x sub 1, applying the correct operations now. By the way, this is negative 3. My bad. The result would be that would be negative 8, and then you will have negative 11, and you will have minus 7s. And since this is minus 2t, when you move it on the other side, plus 2t. This is now the representation for x sub 1, and it uses two arbitrary variables for we let x sub 2 earlier as our s. So again, this is how we solve linear system using this row echelon form, because we expected 3 variables for this, as there are variables, or all of the variables doesn't have an exact value. Thank you for watching.